On behalf of Indian National Trust for Art and Cultural Heritage and the INTACH Conservation Institutes, I extend a very warm welcome to our distinguished speaker and everyone who has joined us for today's talk in the Conservation Insights 2020 lecture series. I am Dr. Padma Rohila, Director, ICI Delhi. Today is the third lecture in collaboration with SUPSI University of Applied Sciences and Arts of Southern Switzerland. I'm extremely grateful to Professor Jacinta Jean and her team for organizing these lectures. Now to introduce our speaker for today, Dr. Patrizia Moretti. She obtained a master's degree in Sciences and Technologies for the Conservation and Restoration of the Cultural Heritage at the University of Perugia in 2011. In 2012, she achieved a studentship for 2 years with CNR ISTM of Perugia concerning the application of non-invasive methods for the study of alterations on artwork surfaces. She got a PhD in chemistry at the University of Perugia in 2018 with a research project aimed to the development of non-invasive spectroanalytical methods for the assessment of cleaning procedures of polychrome surfaces. On this specific field, she continued to work for 1 year as part of her postdoctoral research at the CNR ISTM of Perugia. Currently, she is a postdoctoral researcher at the University of Applied Arts and Sciences of Southern Switzerland, SUPSI, where her present research interests deal with the application of both non-invasive and non-destructive invasive methods for studying artworks, materials, and for monitoring conservation pigments. The title for today's talk, as we all know, is Gino Severini's First Murals in Switzerland, a multi-technique analytical study of the artist's materials. The vast modern decoration in the Church of Saint Nicolas the Myre at Semsales, dated around 1924 to 1926, represents the first mural experience in Switzerland of the renowned Italian artist Gino Severini. The painting materials used by Severini in this church have been characterized by a multi-technique analytical approach, including both non-invasive and invasive methods. The findings correlated to historical and archival research and visual examination by conservators provided significant insights into the artist's materials and techniques. This case study offers a valuable example of multidisciplinary process applied to the knowledge of an artwork. So before I request Patrizia to start a presentation, may I request all of you to please check your microphones and switch them to mute.
Okay. Good afternoon to everybody. First of all, I'd like to thank Padma and Jacinta for inviting me to participate to this series of presentation. For me, it's a great pleasure to present this talk today. In particular, in my presentation, I'll show you a multi-technique analytical approach applied to the study of the paint materials and the paint technologies used by Gino Severini in the Swiss wall paintings realized in the Swiss church of Semsales. In particular, with this presentation, I'll provide you an example of the application of scientific investigation as a support in the before step that last time the Professor Francesca Piquet explained you during her talk. This is an example. In this way, this scientific analysis can help support the preliminary analysis of the paint materials and the paint technique in particular. Gino Severini, born in Cortona, in the center of Italy in the 1883 and died in Paris in the 1966. Is a Cubist futurist famous painter, and his artwork are exposed in the most important museum in the world, for example, in the Museum of Modern Art of New York. Despite his fame like easel painter, his wall paintings production is practically unknown. And for this reason, to fill this gap, a 4-year disciplinary project is ongoing to study the wall paintings production by Severini in Switzerland. Between the 1924 and the 1947, Severini realized wall paintings in 5 churches here indicated in the French-speaking part of the Switzerland. This important research project started last year, is a 4-year project, and is funded by the Swiss National Science Foundation. And the project is entitled Gino Severini in Switzerland, Mural Painting and Catholic Art Revival of the Group de Saint-Luc. The wall paintings are religious wall paintings, and Severini realized these artworks in collaboration with the Swiss local artist group of the Saint-Luc. This is the multidisciplinary research team that working in this project. This team is composed by art historian, conservator restorer, data management expert, and also conservation scientist. I work in this project like conservation scientist. And the Professor Francesca Piquet is the group leader of this important project. In particular, in this presentation, I will show you the results obtained from the analytical investigation performed for the study of the first Swiss church decorated by Severini, the Church of St. Nicolas de Myre in Semsales, that Severini decorated between the 1924 and the 1926. In this church, in particular in the plan, you can see the indication with this number of the 6 different wall paintings realized by Severini, starting from the apse, where Severini realized this wall painting depicting the Trinity. In the chancel area, he realized the Eucharist. In the triumphal arch, the monumental figures of St. Nicholas and St. Sebastian. And finally, in these other walls, he realized the scenes of Madonna with the Child and Holy Family. This is therefore the wall painting study in this important campaign. Concerning the methodological approach used for the study of these wall paintings, the multidisciplinary research team started from a thorough historical and archival research performed by the art historian. And from this research was possible to find many documents related to the realization of these wall paintings, as, for example, noticed by the artist's sketches, but also historical photo. And many of these information are reported in this important book related to a biography and a technical study concerning the artist figure of Severini, and wrote by an art historian, member of our group, Margherita D'Ayala Valva. In combination with this historical and archival research, also a close visual examination was performed by conservators and restorers, thanks to a scaffolding installation. You can see in this picture the scaffolding in front of the Trinity in the apse. And subsequently, scientific investigations were performed directly in situ by non-invasive method, and then in laboratory through the analysis of samples, and therefore by invasive microdestructive analytical method. In particular, I'm a conservation scientist. I'm working this project concerning the analytical part, and for this reason, during this work, I want to show you the results obtained from the scientific investigation, in particular from the non-invasive approach. Concerning the scientific investigation performed directly in situ without any contact with the surface of the wall paintings, we have three specific setup and different methodology. Starting from the multispectral imaging, a mapping technique, very useful to obtain a complete visualization of the painted surfaces using different radiation and obtainable information sometimes not visible by naked eye. Then, after this investigation, it's possible to focus point analysis, always non-invasive, directly on a specific area, point of the painted surfaces, using a spectroscopy technique like X-ray fluorescence and reflection Ftir spectroscopy. Considering the multispectral imaging, this technique allows us to obtain information from different paint materials, and it is possible thanks to a different interaction between the radiation, the different wavelength, and the paint material. For example, in this figure, you can see that UV and visible light have an effect on the surface layer. So with this radiation, we can obtain information about the surface layer, for example, varnish, or the first layer of the paint. Differently, using infrared light, it is possible to obtain information, for example, about the underdrawing, because this radiation has a higher penetration depth. The picture are collected using a modified digital camera without the normal filter used in the traditional camera, because this filter block the UV and infrared light. And in this case, depends on the setup that we want to use. We'll use a different source or filter. For example, in these 4 images, I reported you different setup to acquire imaging in visible radiation, in infrared reflected radiation, or, for example, in UV-induced luminescence. This setup is very useful to recognize the presence of specific organic materials that have an intense fluorescence signal. In this setup, the visible induced luminescence, it is possible to distinguish specific pigments, like, for example, Egyptian blue, blue and purple, and also the cadmium-based pigment. So this is very specific for particular pigments. This multispectral imaging is a mapping technique. For the point analysis and in particular to obtain information about the chemical composition of the paint material, an instrument widely used in the heritage science is the X-ray fluorescence. With this technique, it is in fact possible to obtain the characteristic X-ray fluorescence of different chemical elements. Thanks to the interaction of an X-ray beam with the core electron of an element, it is possible to produce and acquire this X-ray characteristic fluorescence. In particular, with this instrument reported in this picture produced by the thermofixer, it is possible to obtain information about chemical elemental with atomic number higher than 16, equal to the number of the sulfur. Therefore, with this instrumentation, it is possible to analyze the inorganic materials, for example, pigments, metal, but is not possible to obtain information for the organic materials composed by carbon, hydrogen, oxygen. For these materials, for example, the paint binder, we can use another instrument that exploiting vibrational property of the materials. Other spectroscopy technique, like the reflection Ftir spectroscopy. This instrumentation, in this picture you can see the alpha instrument produced by the Bruker optic. This is a compact and very comfortable for the portability instrument. This is a spectrometer that works with infrared light. And this technique in general is high specificity for the identification of organic, inorganic, and also organometallic compounds. And the technique is highly sensitive for the surface molecular composition. Therefore, with this instrumentation, it is possible to analyze coatings like varnish, waxes, but also to obtain information about the paint materials, as pigments, filler, and extender generally present in the pigment formulation, paint binders, but also the composition of the preparation layer of the grounds, as well as the identification of degradation or alteration products, like oxalate or carboxylate, for example. Unfortunately, it is not possible to define the penetration depth of this instrumentation, because the penetration depends on the absorption properties of the materials. But with this instrumentation, it is possible to obtain many information in extended range of the infrared. In fact, the spectra obtainable with this instrumentation are in the complete mid-infrared range and a portion of the near infrared, with other information also about the materials present within the stratigraphy. The distance of the instrument is about 1 centimeter. The measure is very fast. In only 3 minutes, we can obtain our spectrum. So, in the next slide, I'd like to show you some example about the application of this technique and obviously their correlation. In this slide, I reported 4 different images obtained by a multispectral imaging for the figure of this angel in the Trinity wall paintings. And for example, in the infrared reflected light picture, we had the possibility to recognize the underdrawing line poorly visible in the normal incident light, and also by a close visual examination. This is an example. In this way, this multispectral imaging can help us to discover some aspect not visible by naked eye. In the UV luminescence, we recognize the presence of different luminescence phenomena, probably correlated to different pigments. The same things for the visible induced light. We detected a visible response only in the angel's wings. On the basis of these results, the XRF analysis provide important data related to the chemical composition of this pigment. For example, in the area characterized by an intense yellow fluorescence, the X-ray fluorescence evidence the presence of high counts of zinc, ascribable to the presence of zinc white. In the yellow brushstroke of the wings of the angel, the presence of cadmium correlated to the visible induced luminescence effect confirm the presence of cadmium yellow pigment. These are some examples about the correlation of a mapping analysis like the multispectral imaging and the elemental analysis by X-ray fluorescence. but generally to obtain information about many other paint materials, like the composition of the ground or the paint binder, a molecular technique is fundamental. Therefore, in the next slide, I'll show you the results obtained from the application of the reflection FTIR spectroscopy. Here, always on the Trinity wall paintings, the presence of a lacuna in the background, you can see the photo here, allow us to obtain a characterization of the ground layer. Here, an example of an infrared spectrum. In red, the spectrum obtained from the lacuna, in comparison with the standard reference spectra of gypsum and a protein materials like glue. In this area, by FTIR spectroscopy, it was indeed possible to identify the presence of gypsum, calcium carbonate, and a protein material. Unfortunately, a limit of this instrumentation is that we don't have the possibility to distinguish the exact nature of a compound belonging to the same organic class. For example, in this case, I recognize the presence of a protein materials, but I don't know if this material is glue or casein. So this is an open question. The results obtained from this lacuna are in agreement with the notice by Severini. Severini wrote that in this wall of the apse, he found a gypsum plaster, and for this reason he used a secco technique, probably use an organic binder like a protein material. The presence of a protein material was emerged also in all the FTIR spectra acquired for the different painted area, confirm obviously the presence, the evidence of this material used probably as a paint binder. In this graph, you can see also the potential of FTIR to discriminate the presence of specific pigments, zinc white, or in this case, ultramarine blue. But by FTIR spectroscopy, it is possible also to obtain information about the presence of non-original materials, like synthetic organic resin. In this example, I reported the spectrum obtained from this glossy area on the hand of the angel, characterized by the presence of an acrylic resin, probably added in a later conservation treatment. So this to show you the potential of this technique, also to recognize the presence of non-original materials. This is a summary of the different pigments found in these wall paintings by a correlation between the different non-invasive approach. In particular, it was very interesting to find a different black pigment in the background of these wall paintings. Severini used ivory black in the background, and to retouch the edge of the dot, he used a different black pigment, an iron-based black. Moreover, also titanium was found only in the repaintings, because titanium white was introduced in the commerce only after the decoration of this church by Severini. The results obtained about the characterization of the paint materials are also in agreement with the material reported in the invoices. Invoices found during the archival research performed for the decoration of the Semsales church. And these show the thorough correlation between the different methodological approach. For the Eucharist scene, this is a summary of the different pigments found in these wall paintings. You can see, for example, the identification of another blue pigment, the cobalt blue, identified by X-ray fluorescence, but also thanks to the collection of the Ftir spectrum that is characterized by this particular form. Here I reported an example. And also gypsum and kaolinite probably used as filler, in particular in the ochre and earth pigment. In this wall painting was also possible to identify the presence of degradation products like the calcium oxalate. These products are generally formed by oxidation process of organic materials. So this could be an indication of the presence of a possible organic materials degraded over the time. And also the presence again of acrylic, retouching later conservation treatment. Concerning the figures of St. Nicolas and San Sebastian on the triumphal arch, the palette, the pigments are limited compared to the other analyzed for the Trinity or Eucharist scene. In this case, the technique used is fresco. And this is explain also the limited palette used by the artist. Here and also in the San Sebastian, in fact, the presence of an organic material is not clear. It is possible that Severini mixed with the pigment a very little amount of organic materials, but we are not sure. The presence of this material is not clear. For the Madonna with Child and Holy Family, the technique used by Severini is always a fresco technique, and the palette is that typical of this paint technology. Specifically for these two scenes, I'd like to show you an example about the identification of a specific green pigment. By XRF, the presence of chromium emerge in many green areas. But this chemical element can be correlated to many green pigments. The use of a molecular technique that the Ftir spectroscopy allows us to recognize the presence of a specific form of chromium green, namely viridian. This is a summary of all the results found exclusively by non-invasive analysis, starting from the multispectral imaging and then by the non-invasive point analysis, XRF and Ftir spectroscopy. These results were fundamental to plan the sampling. In fact, in base on the non-invasive results, was possible to select the area more interesting and also more appropriate to collect it as sample. In order to investigate more in depth the chemical composition of the materials, in particular in the wall stratigraphy, because a limit of the non-invasive approach is that related to the impossibility to analyze the inner layer. By, for example, reflection Ftir spectroscopy, it is possible to obtain information exclusively from the surface layer. Therefore, the collection of sample is very important to understand the stratigraphy. In the case of the Severini's wall paintings in Semsales, 11 samples were collected, fragments then embedded in epoxy resin to obtain cross-section. Then invasive investigation were performed, in particular by optical microscopy, to visualize the stratigraphy and to measure the thickness of each layer, by scanning electron microscopy to observe the different morphology of the paint materials and elemental composition, and then by spectroscopy technique like Ftir and Raman, that with the use of a microscope allowed to focalize the measure in specific, very small point. Here an example of a sample coming from the background in corresponds to the Severini retouching with the other black pigment that I showed you before. This is the picture acquired by digital microscopy, and this is the optical microscopy image of the fragment collected in laboratory. This is the optical microscope image of the cross-section obtained from the same fragment. And thanks to the cross-section, it is possible to see the stratigraphy of the sample, composed in this case by 6 layers. An important information coming from this analysis is, for example, related to the presence of this intermediate primer layer. In this UV fluorescence image, it is possible also to see a thin layer fluorescence. And this information is obtainable only by the analysis of the cross-section. In the same image is possible to observe the different morphology of the materials. In this table, I reported a summary of the results obtained from the combination of different analytical techniques for the characterization of each layer. And specifically in this slide, I reported a very useful analysis by Ftir spectroscopy in microwave and using a specific detector, the FPA detector, that offer a great advantage, not only the identification of the different molecular compound, but this detector offer also the possibility to see the distribution of the material within a specific area of the cross-section. And thanks to the invasive analysis, in this way it is possible to extend the information obtainable for the characterization of the materials. This was an example about the application of scientific investigation to the study of the paint materials and the paint technique. I selected this case study to show you the correlation starting from the historical archival research until the visual examination and scientific investigation. In the first preliminary approach to the study of wall paintings that regard the complete knowledge about the materials used by the artist, but also the materials added over time. Thank you for your attention.
So, can you see me, Jacinta? Can you hear me?
Yes, yes, I can.
Okay, thank you very much.
You're welcome.
Lizia, we do have a few questions.
Okay.
Take those up very quickly. The first question is from Mr. Srikumar Menon. He wants to know, were false color images generated from multispectral images?
Mm-hmm.
That's the question. Were false color images generated from multispectral images?
About the spectral imaging, I don't understand which is the...
Is Shri Kumar there? Shri, are you there? Can we unmute Shri? If he's there, he can ask the question and we can have the discussion.
About the multispectral imaging.
Yeah, Shri Kumar, can you hear me? He wants to know, was false color images generated from multispectral images? I can't. Shri, Mr. Menon? Okay. I don't think he's there. Anyway, the next question is, what is the voltage of XRF you keep for cadmium zinc-based pigments? What is the voltage you keep for copper and iron-based pigments? Do you need to lower the voltage to carry out with, say, or do you carry out with the same voltage?
The voltage of the instrumentation is depend on the detector used in the instrumentation. And for each instrument is different. For example, in our instrument is 159 electron volt.
Okay. Another question from Mr. Lalit. As you discussed, you were able to identify cadmium yellow with the help of visible induced luminescence. Did you try other MSI techniques to identify other pigments like false color images? Again, a question related to false color images.
Yeah, the presence of the cadmium-based pigment was suggested by the visible induced luminescence. Then the presence of the cadmium-like chemical element was verified by XRF. And then in the cross-section and also in the fragment in the sample was possible to confirm the presence of this cadmium-based pigment by Raman spectroscopy.
Okay. A question from Mr. Joshua Hill. Please could you comment on your experience of using reflectance FTIR in contrast to ATR for transmission, or any caution required in use of reference standards?
The reflection FTIR spectroscopy is very useful, in particular for the surface layer. And the interpretation of the spectra is not so easy. But thanks to the acquisition of a specific database obtainable thanks to the study of many reference standard material, it is possible to a correct interpretation of these spectra. So the limit is related to the interpretation that is not easy, and also about the depth penetration. But the sensitivity of this technique, the specificity is very high.
Okay. Now the next question is, I would like to know the color. This is from Atirai. He likes to know the color chart or the index. Which hue index was used to refer to the colors?
Yeah, the photograph use this check, absolutely. They are not visible in the photo in my presentation, but the photograph use the reference, the color check, obviously.
Okay. What is the penetration depth of PXRF? Is penetration depth also matter for doing analysis?
The penetration of X-ray is higher, obviously, and so in the case of the wall paintings, we obtain also the signal coming from the support.
Okay. Next question from Ms. Anuradha Chaturvedi. She wants you to discuss in a little bit more about FEP detector.
FP?
FEP detector.
FPA detector. Okay. This is a specific detector that allows us to perform imaging about the distribution of the compound. In this case, you have to select a specific band for a specific component, and you have the possibility to visualize the distribution of this compound in a specific layer, thanks to the integration of this band.
Okay, thank you. Another question from Mr. Aditya Kant. What oxalic acid polymorph did you find? Vevelite or Vedilite? And do you find there was any damage in the binder due to the presence of oxalate?
Unfortunately, by in situ non-invasive instrumentation is very difficult to distinguish the form of the oxalate. But for example, in a sample coming from the San Nicolas figure, we recognize the presence of wewellite. Is difficult also to understand the organic materials that following a degradation form this product. We have recognized only the presence of protein in the Trinity, but in the other wall paintings, the identification of a possible organic materials is very difficult, and we are planning more in-depth investigation, for example, by chromatography analysis on samples.
Okay, thank you.
You're welcome.
Question from Keith. She wants to know, is there any standard for false colors to compare with the obtained image? A standard for false colors to compare with the obtained image.
Standard for the multispectral imaging?
I think it's multispectral imaging, yes.
The photograph use always the color check as standard. He collected each setup with the color check, and this is the reference for the multispectral imaging.
Okay, thank you. Another question from Manaswini. Did you choose certain points for XRF Ftir analysis based on non-conformation of pigments with multispectral imaging, or was it done for all pigments and shades of colors on the murals?
We generally, for the X-ray fluorescence, the measures are very fast. So we perform many points, about 300 for the wall paintings in Semsales, for each paint, for each different color. For the Ftir, the measurements are a little bit more complex for the installation of the instrument, and a little bit longer, about 3 minutes. For this reason, we have selected the area to analyze by Ftir, in particular on the basis of the multispectral imaging results.
I don't see any other question. Are there any questions? No questions. So thank you, Patrizia. Thank you very much.
You're welcome. It was a great pleasure for me. Thank you for this opportunity.
I think it was a very informative talk. The fact that we don't have many questions should actually say that.
Okay, yeah, of course.
Thank you, Jacinta. Just a reminder to everyone who has come, the next lecture series is on the 29th of June. We start a 3-part lecture series on conservation of cast and wrought iron. So there'll be 3 lectures on the 29th, 1st of July and 3rd of July, same time. And Mr. Jeffrey Wallace from the English Heritage in UK will be discussing the problems in cast and wrought iron and the repair methods.
And we will see tomorrow again with SUPSI.
Yes, I'll be doing tomorrow. We'll be meeting. Thank you, Jacinta.
Bye.
Thank you.
Thank
Bye.
you. Have a nice evening. Bye.
Bye. Thank you, everyone.